Good day, learners. Welcome back to our chemistry class. And don't forget, where we stopped at in our last class, we were discussing about volumetric analysis. In the last class, we discussed on how to prepare standard solution from a primary solution. In today, we want to look at the practical aspects on the preparation of standard solution. But before we proceed in our class, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent contents. If you could recall, in our last class, we looked at a particular question. Suppose 250 centimeter cube of an hydrous sodium carbonate 4 will be prepared from 0.100 mole per dm cube, meaning we want to prepare 0.100 mole per dm cube of sodium carbonate 4 when it is being dissolved in 250 centimeter cube. We did the calculations using number of mole that give us concentration times volume, and we got 2.65 grams. 2.65 grams is going to be measured accurately using our weighing balance, then dissolved in a volumetric flask. So let's move on and look at the way we are going to prepare it. So this is our digital weighing balance. So we want to use this to weigh accurately our sodium tricarbonate 4. So we have to on the machine and we make sure it's at 0.00 grams because this is 0.00 gram. And this is my Petri dish that I want to use for measurements. The first thing is to note the weight of this Petri dish by putting it on it. When I put it on it, I have 7.8 grams. 7.8 grams. But what I want to measure is 2.65 grams. So it means I'm going to add 7.8 grams with 2.65 grams to look at what it's going to give me. Now when we look at this mass, now this is 7.7 grams. But before it was 7.8. But due to the air resistance around, it is affecting the weighing balance. Now, I'm having 7.7 grams now. If I had 2.65 grams, which is the mass of the sodium carbonate 4, I'm going to have 10.35 grams. So I want to measure 10.35 grams. Now, this is 10.4. So it's measured to 3 signal figures. And so in this case, this is 10.4. So this 10.4 gram denotes our 2.65 grams. Now, to put this in our beaker containing water, then we dissolve it. So this is my beaker. Let me rinse it with this water. So I'm going to pour it here now. I can use my DC water to rinse it well. Then make sure I dissolve it to dissolve completely. So after dissolving very well, after stirring it, everything has dissolved. And sometime we will need to apply it in order to dissolve it completely. Then we transfer this solution into our volumetric flask. So this will now be uh, topped up to 1000 centimeter cube, which is 1 dm cube. So this mark here is a mark of 1 dm cube. So we add our distilled water to it. So now, after filling it with our distilled water, we can now see that it has gotten to the 1000 centimeter key or the 1 dm key. So the solution here now is a solution of 0.100 mole per dm cube of sodium tricarbonate 4. So this is our base. This base can now be used for titration. So we can now titrate the base against an acid using a suitable indicator. So don't forget to subscribe to my channel and click the notification bell for my subsequent content. Thank you very much.